Okay, force method example 2. So with all of these, I'm going to do a part 1 where it's finding the forces and a part 2 for the moments, but for right now, I'm just going to put out all the videos on how to get the forces because the moment is where everything gets really, really complicated. So yeah, let's just get the straightforward method. This is the new part, the finding the moments. It should, in theory, be like statics and mechanics of materials, throwing back to that. So let's go right here. So with this one, it's one of those really tricky problems where they don't give you any numbers, but we can still work with this using the same principles and the same methods. So first thing we do is we find a determinacy. And for this, n is equal to 1, r is equal to 4. We know this again because that's fixed, and that's a roller. There's our 3, that's the fourth. And from this, we know that r is greater than 3n. Therefore, it is statically indeterminate to the first degree. And then for part 2, we are going to be removing a redundant support. And that support is going to be B. So this right here is going to be equal to this loading here, this real loading of W plus this redundant loading of BY. Sweet. So now that we have that, let's get our compatibility equation. Compatibility equation here. This is going to be, let's see, that's displacing downward. That's going up, so this would be B prime, B1. Remember, this is our real loading, and this is our redundant loading. Okay, and with this, we now know that B is going to be equal to delta B1 plus delta B prime. And what is B1 equal to? And then what is B prime equal to? Well, as you recall, this is going to be WL to the 4th over 8 EI, and this is going to be PL cubed over 3 EI. Now, compatibility equation states this equal to 0, and as you know that this can be broken down into BY and then L cubed over 3 EI. We can then say that this compatibility equation is equal to delta B1 plus BY lowercase fbb, and our fbb is equal to this here. So we know that by is equal to delta B1 divided by fbb. And plugging everything together here, we are going to get that by is going to be equal to WL to the 4th over 8 EI divided by L cubed over 3 EI. EI's cancel. W is going to stay out. This and this cancel to just become a singular L. And then all we have left is 1/8 divided by 1/3. 1/8 divided by 1/3 is 3/8, which is 0.375 times WL. That's BY. Now, using our sum of the forces in y, we know that ay minus, boy, this problem. Okay. W plus 0.375 equals 0. Therefore, ay is going to be equal 1 minus this, which is 0.625. Of course, this is WL as well. Now we have our BY and we have our AY. Sweet, awesome, 2 thumbs up. What else do we have to find here? Is that it? Let's see. Oh yeah, AX. Sum of the forces in X. AX equals 0. All right, that's the end of this one. Part 2 will be how to get the moment MA, but there we are. Part 1 done.